today's session is identifying and solve CPU constraints for databases on an Exadata using Database Impact Advisor. My name is Björn Boltoft, and I'm Product Manager for Exadata Management and also a few other products in Enterprise Manager. So let's talk a little about, we had a session 2 weeks ago, and we'll just do a little recap of the features that's available, and everything. So Exadata management challenges, that's one of the things that we see with the customers using Exadata. The machines starting to get larger and everything, they want to have better control of the machines and using the machines more efficient. So we see customers running lots of mission-critical databases on one single Exadata, but lots of customers also have a fleet of Exadata. So, and we see that the deployment type are Exadata on-prem, Exadata Cloud Customer, OCI, and also multi-cloud, where the Exadata is in a data center in OCI or in Azure, Google Cloud, or similar. So some of the challenges that we see is about optimizing the consolidation density and make sure that the performance keeps and are stable in that environment. And since it's a shared infrastructure, that's a big challenge. Another thing is about improved productivity. With the automation, make sure that when you have lots of databases, Exadatas and everything, and need to upgrade, then it should be automated to minimize human errors. Maximize resource management. Make sure that the databases that needs resources get the resources. That increase the utilization of an Exadata and increase the performance of all databases on the Exadata machine. So that's single resource level and aggregate levels as well. And ensure reliability performance. Identify noisy neighbors before they become a big problem in the system. Make sure they don't hog all the resources in the environment. Detect outliers and various levels, both databases, VM clusters, and rack, to identify where we have the resources utilizing. So with that, we're using the Exadata Management Pack. These are a set of new features that was delivered in August. And now we're starting to get customers using them. So it's more important also that we have the deep dive session. So understanding the features and functionalities that's available here. So we have set of functionality using for analyzing. We can analyze single Exadata, Exadata fleet, and visualization through dashboards here. This was the last session where we talked about the dashboards. This session is more about the advisors. So we have two different advisors. We have CPU advisor, which is this session, and we have IO resource management advisor, which is next session. Automation, a fleet scale Exadata infrastructure patching, and AHF management, improving the productivity and the security and compliance on your Exadata machines. So that's an upcoming session later on also. We do have support for any type of Exadata configuration. That's on-prem Exadata, Exadata Cloud Customers, and Oracle Cloud Infrastructure, and multi-cloud environments, as we said before. Key features in the Exadata Management Pack are Exadata Fleet Dashboards, Autonomous Health Framework Administration, Exadata Infrastructure Patching, Database Impact Advisor, IO Resource Management Advisor, And we have some other minor features with Exascale, interactive IOPS visualization, Exadata Cloud Database Inventory visualization. By using the pack, we provide and ensure that the configuration can be consistent across the fleet and hardening the security and compliance in your environment also. We also working on all this automation, which improves the DevOps in efficiency by up to 70% from using the resource advisors and all the automation. And of course, we have the optimized resource utilization. So that's something that is rather difficult to set time or something like that. It is just make sure that your database is working better than they did before. So just a little recap about the features here. Automation. Here we have the Entity Systems Autonomous Health Framework Administration, where we can install, upgrade, and check everything with the AHF. So you can deploy the latest AHF releases in all your Exadata environments. Configure AHF auto upgrades. You can schedule and configure ExaCheck compliance checks, so they're running on a certain interval. And you can schedule ExaCheck auto runs and also. And of course, you also have the ability to run on-demand ExaCheck and AHF CTL commands. For this framework, we have the ability to monitoring everything. So you can monitoring all your upgrade status and history. Make sure that you have the latest ExaCheck available and installed on your systems. We have information about AHF service status, AHF auto run and auto upgrade configuration, so we can see exactly what's happened if there are any issues and problems on the system. ExaCheck run status also and history. That's available. And it's a simple framework. So, for example, if you want to install or run a command, you execute it, and it will select all the nodes in the Exadata system for you. The automation, the Exadata infrastructure stack patching is available. So we have it's using the same interface as the database and grid patching components, and it's possible to automate all your patching, monitoring, and secure compliance, and everything is set here. So Exadata stack with the storage servers, KVM guests, and Sendom use storage servers, InfiniBand switches, and we will also add the Rocket switches very soon here. We have scheduling the patching, so you can schedule these patches, and you can do that. You can have the compliance check afterwards and make sure that everything works. If there is a problem, then there will be a rollback on the system. And we're supporting this type of patching, either using the UI, EMCLI, or REST API. The dashboards that we talked about last week, we have currently 4 different dashboards. It's fleet configuration, where you have all the details about your Exadata configuration. The overview, which type of Exadatas you have, hardware, which generation of Exadata, and then which software. So here it's easy to identify everything about your Exadata environment. You will also get aggregated capacity and fleet capacity and component capacity, so you can see details of on individual levels. Like I have 10 Exadata, I can see that the total utilization is a certain amount. I can then go into deep depth and looking at individual Exadata, which one is highly utilized, which one has capacity over, and then even going into fleet components. So I can look at individual nodes in the Exadata machine. 2 nodes may be highly utilized while 2 others are less utilized. And therefore, we can do the balancing and make sure that everything is structured in good ways. So the last thing is about the resource advisor. We have the IO resource management advisor, where we providing heat maps and line graphs about the utilization, IO utilization per database, per CDB and PDB in the environment. So we can set filters also, and looking at heavy used PDBs and CDBs in the environment. And of course, we're using the line graphs also to get a more in-depth view of what's happening in the system when you have some issues, where you have peaks and where you don't, where you have your values in the system also. And the last thing that we're talking about, and this is the subject for today, Database Impact Advisor, which is integrated with AHF balancing. So that's a way to have a system-wide Exadata CPU usage analyze. You can identify databases impacted by noisy neighbors and all that type of things. Summary of the impacted and exposed databases, how much time and so on. So let's go into depth and talk a little more about this, what's available here and what we can do. So first of all, the Impact Advisor is something that we can extract for every individual cluster and database on and one single Exadata. We have the possibility to correlate instance level impacted periods, so we can see exactly when it occurs. We can look at events, what type of events that happen. We have the CPU usage and non-database CPU usage. And we can do this on per instance as well with the database resource management guaranteed limits to look at all these details. So first, a little about the concept about the Impact Advisor, why we're using it. First of all, what we see here is every database have a CPU count, and it can either be set using the CPU count parameter, or it can be unset. If it's unset, that means you have access to all the CPUs in the environment. The CPU count limits the number of CPUs that a database is permitting to use simultaneously. So in this environment, let's say we have 40 CPUs. A single database may have, in this case, 25 CPUs. And that means you can never, ever be beyond 25 CPUs during the time. Another thing that's also important to know is, where is a good limit on the database? We have best practice saying that 70% is considered to be a healthy utilization. And that means the average. If you peaking above and going beyond, that's not a problem. But if you always are beyond, then it may be a problem. We will see that later on, what's happening here. So it's maybe those spikes that causing the problem. If we're looking at spike workload, the former was more stable every time using the same situation. Situation is quite common that each database should have, we can do the partitioning of the system. In that case, we have dedicated CPUs for each individual database. So every database may have 60 cores available, and then we set in, for example, a certain database have 40, 20, or something like that. It will never go beyond that, and other databases may have the rest of the utilization. But if we're looking at this graph and we say that, okay, we just have one database of the system, then we provide the ability to spike. But there are lots of times when there are lots of resources available. That means it is we give the database the advantage of performing in isolation. But the disadvantage is that we have low CPU utilization across each individual cluster. So that leaves lots of CPU resources available, and it can't be consumed by other database because we have partitioned. We have set this as a limit. It is purely for this database. And of course, we set that as a 70% spike as well. Here we have the limit if we say that we spike at 40 cores, but that means that we have around 54 cores available. We should set the system to 54 cores. And we see that spikes are very general, around 40, but the normal utilization is around 15, 20 or something like that. That's a more high utilization. That leaves us about 40 cores available. So what we can do instead is that we can do an oversubscription. So in the same system here, we have 64 cores and we have 4 different databases. So we add the amount of CPUs. In this case, we have not caged anything, so every database can use all the resources. That means we can borrow from anyone in this situation. We can oversubscribe 1, 2, 3, 4 times, depending on how much resources that's used in average and when. So if we take 2 databases here, and we see the spikes. Instead of where we have the spikes on 40, we have now a more general workload running around 25, 30 cores. And instead of 40, we have a spike of 55. So we have decreased the amount of usage that's needed. And that's what we want to do. So we have we might need to add a little more CPUs than we had before, but it's a small difference compared to what we had before. And we still are on the same 54 cores or something like that, helping us to get more stable. If we peaking a little above, then we can have a longer peak, for example, like we get a little more resources utilization and that taking a little longer time before we get to stable variation afterwards. So we allow the CPUs to be available for all the databases. Better overall CPU utilization can be achieved. Less CPU capacity is wasted. Disadvantage is that performance may be erratic or even poor in certain occasions. And if the databases deployed in the cluster do not have spiky workloads, then we are in a really bad situation. That can be disastrous. So let's take a look at this oversubscribed system and look at it from a balanced view. We have 3 databases here. None is using more than 25% of the workload. So there are more or less 25% available. All database will get their resources. There are no problem at all. And if one database should spike, then they can spike quite much, more or less 20-25% before there will be a CPU resource constraint. But if we're looking at our databases, one of the databases here, it is database A. It starts to increase the workload. As long as we still have available resources, that means this database will get their resources up to 40% here. The available or non-database CPU will decrease, certainly if there is availability. And database B and C is still getting their 25% of the resources. We are still inside the limits. There will be minor problems in this situation. If we see that this database starts to increase even more, now we have the same database started at 4% instead. It's go up to 150% of what it's started to use. So in that case, we have an oversubscription. So we have 2 times oversubscription. And this database will actually not get the resources it's asked for because there are not resources enough. The same will happen for the other databases because we have no instance caching. Everyone can use their CPUs. So they request 25% of the resources. But as we see, they will not get their amount. So we are above the resource limit. And that means that the total workload will take quite much longer time. So let's say that if we're starting with one user, one CPU, and it's always using that CPU for an hour, that will have a workload that's running for an hour. As long as it's alone, then it will take an hour. As if there is someone coming in and saying, I also want that CPU, then the workload will take 2 hours instead for both of them. So, and the more we're adding, the longer time it will take. And if we are in the situation where the resources are exceeded, that means that it will take time for this workload to get into a stable situation again. If we're looking at the same situation, the first database is still trying to use the 150% that it asked for. But now database B and C is also increasing their workload. What we can see here, as long as database B and C is not increasing their workload, then database A will increase. But in the situation here, that's hour 4, where they start to increase to 50%. That means that database A will not get their resources either. So it will drop in the performance and have less resources. And that's where we see a quite disastrous situation. None of the databases will get their resources, and they will be competing about the resources. The system is, in this case, very heavily impacted, and we have oversubscribed with 4 times in that situation. So let's try to iron out what we can do in this case. This is more a normal situation where we have 2 different workloads. We're starting with workload A, and they have their peak 40%. It's a spiky workload, and we are around 70% utilization. Then we're adding next So if we see both these spikes and we see that, okay, we need 40 times 28 cores, that means an increased workload. But in reality, what we can do is the peaks are not aligned. Therefore, it is possible to reduce. We have database migration planner that can help you with this type of consolidation, where we can do the planning, we can give consolidation advice about how to set up this. It can help you with the migration if you need to migrate databases between Exadata environments on-prem, and it can validate by using real application testing. For that, what we see provide is line graphs, similar to what I had in my, where we can see the total resource utilization for each individual database and for combined situation where all databases are peaked and aligned. We can provide the best matching, how to set up your databases, where to configure which and how much resources they need in the mapping. So here we have a set of databases, each individual database using a certain amount of resources, and we're providing details about how they will manage in the new system. But back to the database impact advisor here. So with the consolidation of these workloads, we just had a minor increase. We said that we had the 68 cores that was more or less needed if they had been on their own system. But now we can spike on, and the spike is on 55 cores. That means we have reduced the amount of free resources needed. And if we adding a third workload here, and we see this type of spikes, we can now see that the total should be 99, but still we have the spikes not non-aligned. That means we ending up at maximum resource utilization 59 cores. But what happened if we have aligned peaks? Then we will see that there is a very high utilization. This is what Migration Planner helps you to identify where you have spikes, when they align, and how much resources you need for a certain time. So let's now go and see what database impact advisor can help you with, and how we can identify and look at this when it's actually occurring in an Exadata environment. So database impact advisor is the tool that will help us with this. We will be able to look at the high and low, the identifying where we have these type of spikes, how much time we are in this spiky situation. And that's where database impact advisor can help us with. We log into Exadata, and in the menu, there is a database impact advisor. This is for the complete Exadata. Here we have 6 different clusters. We just see 5 of no, actually we see all the 6. They are not in the correct order, but we have 6 clusters, and we can see different information about the clusters. We have one cluster that failing to provide us with the resources that's needed. We have the other clusters are either just around the usage, and 3 of them are passing. They have no problem at all. We can see that certain databases have problems. It's not just the cluster by itself that gets the problem. 1 or 2 databases in each cluster may have problems. So we see 2 databases that failing. and one database that gets a warning. When a database fails, that means it doesn't get the resources. It is impacted. So we have resource constraints. And that's the 70% limit that we're talking about. A database with a warning, it gets its resources, but it's exposed by other databases. So it will, if other databases start to use more resources, then it will also be an impacted database. We have information about the instances because it could actually be that databases have impacted on one node, but not on the other node. And this is what we get information about here. So we have information about impacted instances, hosts, and everything. So we can identify the instant health on each database. We provide information about how much time each individual database is exposed or impacted by other databases. We're using the 30 last days of statistic to get that information. As we can see here, we have information about allocated CPUs. The total system has 64 cores, and every database in this environment, the first cluster, using all the CPUs. There are no caging. We have no restrictions of the databases. And therefore, we can see individual databases if they're failing. We can also see individual instances if they're failing. How many hours they are either exposed or impacted. In the situation of the Siebel database, it is only exposed 1 hour, but otherwise it's working fine. That's the Siebel database warehouse. The Siebel database, they have exposed hours 31. So during that time period, if other databases start to increase their workload, this database will not get its resources. Impacted 41 hours. Other databases have already started to increase their workload. Therefore, we get impacted in this situation. So let's look at this situation here. This is the warning database, the Siebel data warehouse. We have 1 hour of the 674 hours where we have this impact. We can also change the view. So instead of looking at it in a table, we can look at different clusters. So here we have all the clusters. And now we can see the size of the cluster and the size of the database. So the VM cluster number 1 is much larger than the other one, and therefore it's taking more of the space. Each individual database here now is smaller or same size. It's have no restriction, and we can see that over the complete cluster and everything, and see how much availability we have. We then do a small change. So we're setting CPU count to the Siebel database. We're restricting that database to have less CPUs. What's happening now is we see this database, it's smaller in size in the cluster in the heat map view here, and therefore it's getting more details. By selecting the database, just selecting it in this view, we can now see exactly when it is exposed or when it's impacted. Here in this situation, we have a certain amount of hours where it's impacted, And exposed, we can see the guaranteed amount of resources for this database. So the guaranteed resources, since we have 4 databases, 64 cores, the guaranteed is 16 cores. And everything above 16 cores will then be a exposed hour. We can then go into individual instances. And here we see the same graph as we saw in this previous. We now see the individual instance, but in the lower section, we also see have more details. So here we can see the total amount of usage for all the other databases. And the green line is also telling us about how much usage we have of non-database usage. The 70% limit, so that's about 55 cores in this case. We have the total amount 64, but 70% limit is, in this case, 45 cores around. And every time we peaking above that line, then we fail. Then we are not guaranteed the resources. We have some issues. So we get all that information and we see the impacted thresholds and everything about the limits on these databases. We can also see these details. So now we're just looking at this graph as it is, and then we can highlight the impact hours. Every hour where we have some issues are highlighted. So now we know exactly when a system has some issue. And we can also correlate this with incidents. So we can identify every type of incident that's occurring. We see the file as well. So we can actually go to this alert log file and looking at the details, exactly what's causing a certain issue. This was Aura 600 in this situation that we have here, but it could be other issues as well. And next part is to looking, we see, as we said, we saw the server, how much utilization we had, and we saw all the other databases, but what we also can do is we can do this for every type of instance in the environment. So here we have all the instances instead where we see this type. Now we can see which instance or which database that's actually using the memory or using the CPU during this time of when we're using it. So as we can see, our database, the first one, the Siebel database, using quite lots of resources. The other databases are using quite much resources. That's the SFA database that's actually using a high amount of resources as well. So this helps us to understand which database that's consuming the resources on the environment. And by hovering over, we can just see the different, we can see the instance that's actually causing the problem also. Now we know quite lots of this, of why we have a problem, but how should we actually solve the problem? That's where the AHF balancing report helps us. So the AHF balancing report is an in-depth analysis of all the CPU resource utilization in the cluster and at the cluster and database level. And it will recommend for the optimized DB resource management setting within a cluster. And that's where we go into, I have one file here. So this is a balancing report. Here it is another cluster. We see the time period when it's starting, when it's ending for this cluster, and we have collected 792 hours of statistic for all our databases. We identify exposed, impacted, so that helps us to provide, is it passing, if there is an info, or if there is a warning and a failure. What we can see in this situation here, we have 32 cores available. We have almost a third of the time, 251 hours that it's exposed. And we also have 250 hours when it's impacted. So this cluster is heavily utilized and there is a problem with the cluster. By doing some changes, we can actually reduce the exposed hours to more or less zero and impacted hours to zero also. That's by doing a very small overallocation. As we said here, we have overallocated 3 times more or less. Now we're just overallocating with 1 CPU. Here we have the current situation. We can see all the details about when it's failing and when there is a warning, because here we have a warning also. If we implement the advice, we will now be able to see that we have more or less no impacted hours at all. And that provides us with the details. So for each individual instance, we will get into zero. And here we have for each individual node in the cluster also. So how do we solve this? We have the action plan here. So we have 4 databases where we should reduce the CPU count, not using the full CPUs. The first database, the current situation is 32 cores. By setting this database to 5 cores, we reduce the utilization and the sales. Also 32 cores, getting down to 5. The most utilized database, the DBSOE, is using 32 cores, but here we reduce it to 21. That's a healthy limit for this system. And the CLV1, which is a test database, it's going from 4 to 2 cores. And now we can see for each individual database, do we have exposed or impacted hours? It was the DBSOE that was impacted and exposed before, and now it's reducing and it will not get impacted at all. We can then look at this from individual database also and see the current timeline for current and recommended configuration. If there are data missing, then if there are more than 10% of data missing time points, then that will be something that we inform you about, and that helps you also to see, is this something that we can use? Is it a situation where we can live with, or do we need to wait until next time when we have more data available? So by this, we actually at the end of this session, and we have information about this. So we have webs where we have the Oracle.com Enterprise Manager. We have a set of videos on YouTube, Enterprise Manager. We have blogs in blogs.oracle.com, Observability, and of course, Enterprise Manager documentation, where all this information is available also. So with that, we have 10 minutes for Q&A. Are there any questions that we should bring up live here?
As a reminder, you will be sent the replay once that's available, and I will also put the reminder link for our next session in that email. Oh, looks like we do have a question.
So this question is actually the next level. So here we have a 3-node rack cluster. We have 2 databases running, and in one node we have a higher workload. It's consistently higher, it looks like also. More average active session, and more database time. Here we would like to know if the higher query execution or workload being directed to node 3. That means you actually need to use AWR and Ash. It is really not something that the impact advisor helps you with. You can, of course, reduce the amount of cores for if there is one database. So you trying to set the limitation for that database. But in that case, we need to understand the details of each individual instance. What type of workload? Is it are you using different services in the database that's causing more connections, or is it a certain amount, a certain background job or something like that that causing the problem? It is very difficult to identify just straight off. You need to have more details about that type of why it's causing. If you have multiple databases, some databases have using 2 nodes and other databases using two nodes of their cluster. That's more that we can use in that case. That's helping us in a better way.
And then we have a second question. Does the AHF balance, in addition to CPU count recommendation, set the DBRM profile accordingly with those recommendations? The metric used here in the impact analysis is pure weight on CPU, right?
Yeah. So the impact advisor using the CPU count in the database. As long as you don't have any settings of the CPU count, every database can borrow resources from other databases. But as soon as you set in the limits, and this is what the impact advisor helps you to say, the limit for this database is X amount of CPUs. In the case we had, we can go back to the report here, and what we saw here is that the current situation, 32 cores, this database can use all the CPUs. We recommend it to be set to 5. That limits this database. So it is a database IO resource, database CPU limitation that we implement on that database. If we go for pluggable databases inside the database, we do currently not have the same type of recommendation. The database by itself can be provided with the recommendation. Don't use more than this. That might be the next step of this feature, where we can reduce and say that a certain pluggable database should not have more than, in that case, if we have 2 pluggable databases, one that have 4 and another one with 3, we do over provisioning there as well, in the same case as we may do over provisioning with the impact advisor. But currently we do it on database level, and we set the limit how many CPU resources, and this is the init.aura parameter CPU count. That's set.
Looks like we have one more question. In the example, RATDB is changed from 32 to 5. It will start for CPU when it needs it, right?
So if we set this database to 5 CPUs, it will never exceed 5 CPUs.
And was the max 25 for that, Bjorn?
So the maximum here is 32 cores
Okay.
in this one. Here we have the total subscription of recommended is actually in the end that was 33, I believe. So yeah, the total is 33 CPUs with the recommendation. We have a slightly oversubscription. Sometimes there might be some databases that increase.
Are there any new features added to monitor the database on Exascale? Also a question.
Okay, that's another topic, but yes, we have both Exascale in standard enterprise manager feature for Exadata, but there are also a few new features available for in Exadata management pack also. But
Thank you everyone for joining this call. If there are no more questions, I can conclude this call. Have a great day, everyone.
thanks.